We have been told that we are currently living through the AI revolution. We see large language models writing code, generating art, and predicting consumer behavior with uncanny accuracy. But behind the curtain of this progress lies a fundamental limitation. Classical machine learning is a linear process operating in a flat world. As our datasets grow from gigabytes to petabytes, and as the complexity of the patterns we are trying to find becomes more entangled, our current AI models are beginning to choke on the sheer volume of the math. We are approaching a frontier where adding more GPUs is no longer the answer. To find the next generation of patterns, the ones hidden in the noise of subatomic physics, global climate shifts, or chaotic battlefields, we need to move beyond classical neural networks. We are entering the era of quantum machine learning, or QML. This isn't just about making AI faster. It is about giving AI the ability to see in dimensions that don't exist for classical computers. To understand why classical AI is hitting a wall, you have to look at the dimensionality problem. Imagine you have a massive pile of mixed-up colored sand and you are trying to separate the red grains from the blue ones. In a two-dimensional world, these grains are all mashed together on a flat surface. There is no clear line you can draw to separate them. Classical machine learning tries to solve this by creating complex decision boundaries, essentially trying to draw incredibly squiggly lines through the sand. But as you add more variables, the lines become so complex that the computer eventually loses the thread. This is why AI hallucinates or fails to find correlations in massive datasets. It is simply overwhelmed by the complexity of the flat math. Quantum machine learning solves this through a process called feature mapping into Hilbert Space. Instead of trying to draw squiggly lines on a flat surface, a quantum computer takes that pile of sand and lifts it into a high-dimensional mathematical space, a space with potentially thousands or millions of dimensions. In this higher dimension, the red grains and blue grains naturally drift apart. What looked like a chaotic mess in 2D becomes a clear, separated pattern in the quantum realm. By processing data in these high-dimensional Hilbert spaces, a quantum neural network can find correlations that are mathematically invisible to even the most powerful classical supercomputer. We are talking about the difference between looking at a 2D shadow of a tree and seeing the actual 3D tree itself. The tactical implications of this are immense, particularly in the realm of pattern recognition within denied or noisy environments. In modern electronic warfare, an adversary will try to hide their signal inside a wall of artificial noise. Classical AI often struggles to distinguish between the two, because it treats every data point as an independent variable. But QML uses quantum entanglement to look at the global state of the data. It recognizes that the noise and the signal are linked in ways that classical logic cannot detect. This allows for real-time decryption of signals and the identification of stealth threats that would otherwise remain hidden. It turns the noise of the battlefield into a map of the enemy's position. Furthermore, QML offers a solution to the energy crisis of modern AI. Currently, training a single large-scale model can consume more electricity than a small town uses in a year. This is because classical transistors have to physically move electrons through millions of gates to perform a single calculation. Quantum machine learning operates on the principle of quantum parallelism. Because the qubits exist in a state of superposition, a single quantum operation can process a massive number of states simultaneously. This means we can achieve a higher level of intelligence with a fraction of the energy. We are moving toward a future where we don't need football stadium-sized data centers to power an intelligent system. We just need a coherent quantum processor. We are currently in the hybrid era of QML, where we use classical computers to handle the data storage and quantum computers to perform the heavy-duty pattern recognition. This is the ultimate force multiplier. It allows us to take the massive amounts of data we have already collected and run it through a quantum filter to find the insights we missed the first time around. We are going to find new drugs by seeing patterns in molecular folding that we thought were random. We are going to find new economic signals by seeing correlations in global trade that appear to be noise. And we are going to build autonomous systems that can truly sense their environment with the intuition of a biological organism. The race for QML is the final stage of the quantum revolution. It is the moment where the power of the quantum processor meets the flexibility of artificial intelligence. The nations and companies that can successfully map their data into Hilbert Space will have a cognitive overmatch that cannot be countered by classical means. They won't just be faster, they will be operating on a different plane of reality entirely. The era of the linear AI is ending. The era of the quantum brain is here. If you want to understand how this cognitive shift will redefine the late 2020s, stay with us. The patterns of the future are waiting to be revealed.